Hello. So in this video, we're looking at mappings and functions again. But this time we're being given a function or the equation of a function, and we need to sketch the graph, so draw what it looks like, state the range of the function, so kind of the range of the possible y values, the outputs, and then we have to state whether it's a one-to-one or a many-to-one function. All right, so if we scroll down, I've kind of already written them out. So our first one was 5x plus 1. So we need to draw that. And you're only sketching, so we don't have any axes that it has to be perfect for. We basically need to think, what will this look like? So this is a straight line equation. The 5 means it's going to have a gradient of 5. And the 1 means it's going to have a y-intercept of 1. So I'm going to let this be my 1. And then it's 5x, so it's quite steep. I mean, there are no labels, so it doesn't really matter how steep you draw it. But I think maybe draw it kind of like that also. Yeah. And all I have to do really is label this point here as being 1. And then I probably need to label this point here. You always want to label all the points where it crosses the axes. So if I let this equal to, we'll just work this out over here. If we let this equal to 0, yeah, because we say our equation, 5x plus 1, equals 0 because it crosses the x-axis. Then I know that 5x equals minus 1, or x equals minus a fifth. So this point here, I'm going to label as minus 1/5. And that's it, I've sketched my graph now. That's perfect. However, it says that our domain is when x is more than or equal to 0. So I actually don't want to draw this entire graph. I don't want to draw parts of it. I only want to draw it for the x values that are bigger than 0. So all of this stuff over here. So actually, I would now cross all of this bit out, and I would only leave this part here. Yeah, so in the exam, you'd want to only draw this bit. I think often with these ones, it's better just to draw the entire thing in pencil and then rub out the bit that you don't need. And the more used to it you get, or once you're more used to it, you can start just drawing these bits. But anyway, that's how it works. So then we need to work out our range. And for our range, it's going to be, this is our y value, here 1, and we're getting 1 and anything bigger. So 2, 3, 4, 5, anything bigger than that. So our range is just that fx is more than or equal to 1. That's it. And then for our mapping, so any x value, like this x value corresponds to only one y value. So it's just a 1-to-1. Because also each y value can only be achieved from one particular x value. So 1 to 1. And that's it. So going down to b, this time we're doing x squared plus 3, and only for the domain of when x is more than or equal to 2. So first of all, let's roughly draw x squared plus 3. So I know an x squared graph looks kind of like that. But then if I plus 3, I'm going to shift upwards. So actually, I'm going to draw it roughly like this. Okay, that's not kind of perfect. It wants to be its lowest point, just here. And so this value here would be 3. However, I then want to consider this domain. So actually, I only want to draw the graph when the x value is 2 or more. So x being 2 is like somewhere around here. So I can sort of imagine it being like this. So actually, I only want to draw it from this point onwards. So I kind of want to get rid of all of this. And I only want to draw this bit here. So if this was an exam, I'd make sure that I only draw this bit. Okay, so that's that bit drawn. Then for the range, basically I can have any y value bigger than this point here. But I need to know what that is. So this was 2. And if I plug 2 into my equation, I do 2 squared plus 3. That gives me 4 plus 3, so 7. So this y value here is 7. Which means that my range is any value bigger than or equal to 7. So we can say that fx is more than or equal to 7. So that's the range for that one. And if we look here, each x value will only give us one y value. and each y value can only be achieved through one x value. So this again is a one-to-one mapping, or a one-to-one function. All right. Then we have C. So here we have the square root of x minus 1. These ones, to be honest, are a little bit harder to draw. So don't worry if you find it a little bit confusing. You kind of have two ways to draw a graph if you're not really sure how it looks. One, you can just take a whole bunch of x values and just plot them on. So kind of mark like 1, 2, 3, 4, 5 on the x-axis, and then find out what the y value would be at each point and plot them all. Or you can kind of think about it, like ignore the -1 for a second and just think of root x. Well, as x increases, root x is also going to increase. But weirdly, root x won't increase as quickly as x is increasing. So even though x is getting a lot bigger, root x, which is our y, isn't getting so much bigger. And when x is 0, y will be 0. So we're going to get something like that. Yeah, that's what the root of x looks like. If I were you, I'd try just to memorize that, but you can also figure it out. And then because of this -1, that means it's going to be shifted to the right by 1. Remember, it's always a bit confusing to think -1 you go to the left, but actually go to the right. So it's actually like this. Right? And we only are after it for when x is more than or equal to 1. So actually, we only care about this point here onwards. So this is 1, and our corresponding y value at this point is 0. So actually, our range is just any value bigger than 0. So fx is more than or equal to 0. Yeah, because here, y is like a half, 1, 2, 3, 4, and so on. So it's any value bigger than 0. And this actually won't actually plateau. That's not meant to look like it's plateauing. It will keep on going up. And so as for our mapping, again, each x value only has one y value, and each y value can only be achieved by one x value. So this is a 1-to-1 mapping. Awesome. So hope that makes sense. If you have any questions, let us know in the FAQ, and otherwise I'll catch you next time.